My name is Nando Ochoa. I'm a professor of smart grids and power systems, part of the department of EEE. And why am I teaching grid integration of renewables? Because it's a very exciting topic, and I'm an expert in distribution networks and integration of renewables and other technologies to distribution networks. So that's the actual part that I deliver as part of that particular subject.
So this is Pierluigi Mancarella. I'm the chair of electrical power systems here at the University of Melbourne, I in this subject I teach after this, like complementary to Nando's part. So when Nando presents, he just said distributed resources, distribution networks, and all that. Actually, I deal with system level analysis of renewables and in general low carbon technology. So what is the impact on system operation, impact on economics, on markets, and all that. So it's pretty unique subject. But by the way, this subject is really historical because we've been teaching something similar with Nando for more than 10 years. So basically, we're teaching this kind of subject for decades now, and we still think this is like unique in the world, actually, because there is no other subject to our knowledge list that has got together technical aspects, economic aspects, system level aspects, and sort of distributed resources aspect, everything together with a comprehensive picture. So I think whoever is going to attend this class should be consider themselves pretty lucky. There are two aspects of that. One, of course, is the one that's got to do with the capability of analyzing in a quantitative manner current and future energy systems. Of course, the student will acquire like unique toolboxes really to be able to assess different things that got to do with low carbon technologies, from planning of a wind farm to assessing the input distribution networks of electric vehicles, and I was saying all that. And this aspect of the quantitative assessment is really essential because, unfortunately, renewables and low carbon energy in general now is everywhere. I say unfortunately, it's not, of course, it's good. Everyone is talking about it. The problem is that everyone is mis-talking about it. Everyone feels entitled to talk on YouTube or to put something on LinkedIn. Then we need to understand who can be trusted and who can't. So what I always say to students is like, they will learn not to believe what they hear on TV. But in the sense that everything is much more complex and complicated. They will understand here how to talk about numbers, not adjectives. You will find the subject extremely different. It still got all the sort of quantitative part with equations and calculations, like more or less, hard from that perspective. But what you will find is really that you need to think a lot and gaining some sort of critical spirit.
So this is not about learning that particular tool or that particular tool that everyone will want to use it. Now, the tools are available. You can learn them in 6 months in any company. Doing quantifications as a quantification per se is not necessarily that complex. Putting everything that is needed to do the quantification to really answer the question, of can you have this PV farm here, without affecting this particular part of the grid? Can you have many houses with electric vehicles in the next 10 years? And what are the implications of that? Having all the different concepts all together to then do the quantifications is what really matters. And we don't even have enough people in industry really doing or putting things together to do this quantification. So just when we talk about tools, it's not really about the tools per se, it's all the understanding that comes together to achieve those assessments. In general, you should have power system analysis as a background, definitely introduction to power engineering. So in general, yes, it's for electrical engineers.
There would be full sets of lectures and tutorials where by hand, actually, you will be able to assess what happened to South Australia. There are lots of real world studies we will do. For example, you may have heard of what happened in Texas with the cold spell in Texas and the blackout, the rolling blackout in Texas. So you will actually learn the tools, how to assess why the kind of events happened and what could have been done. In the case, you will learn the tools to understand why the system operated in those conditions during South Australia blackout, why there was the blackout. Can we really blame renewables or not, or actually something smart could have been done to prevent that?
This particular subject allows us, because is one of the final ones of the masters, allow us to provide a little bit of insights on our research. Our research is not just, of course, limited to interesting papers and reports. This is all done in collaboration with the industry as well, and in many cases as well, trial in actual projects. So we will share those findings as well.
At the end of the first part, when basically we start describing how the new distributed energy resources can be aggregated and start participating in system operation market operations as conventional power plants. So we call actually virtual power plants. Now they can be intelligently aggregated and participating in the market, like for example, combined cycle gas turbine. So you understand, like for real, and actually you will be able to quantify this. You will really like experience it really like you will build somehow the transition. You will see it's really exciting. And then in the second part with Nando, you will see even more details about in order to have this, what else is needed at the level of distribution network to make sure that the integrity of the network is still preserved. So it's pretty unique in terms of how we provide the big picture, and hopefully, again, everything that you would see is happening on TV, really, and everything else, you will really now be able to assess deeply, understand deeply what there is behind.
This is a very good question because you can argue, well, the whole thing is about writing essays and concepts. No, there is a component of that because that's how we assess understanding to some extent.
Yeah.
But I think that's the part that is unique to our subject. We have managed to let's say water down those concepts into simple exercise. Well, they look simple to us. The moment that the students do it, it's not as simple, but relatively simple exercise where you can actually, without a software package, just by doing calculations, you can actually put all these concepts that we're discussing into practice, to numerical practice, and then really find answers to all that.
You'll find it difficult to solve the exercise in a sort of automatic way. You really need to understand conceptually what there is behind. In a way or in the other, that is really what a modern electrical or energy engineer really needs. Besides that, of course, we also have something that is more sophisticated, like particularly in the workshops, but there will also be other like small tools that we make available online for the students to see a little bit more details besides what we do actually by hand. There will be some aspects of economics, as you will see, that normally you would have learned in power system analysis, but we teach everything that is really needed. So overall, an engineer should definitely be able to wouldn't have any problem.
If you are a student that is interested in renewables, is interested in climate change, is interested in how the electricity sector can actually help decreasing our carbon emissions, I mean, this is the subject for you to really understand how this can actually be done from a technical perspective.
So who would you trust more, a politician or Maxwell and his laws of physics?
So we are not blind to that. We will discuss it. We will mention what are the implications in some decisions, because it's part of life. But the core is really on the technicalities and the physics. We discuss about photovoltaics, batteries, electric vehicles. but not really looking at what is the technology behind. More about the integration. I mean, so we will always have different technologies, but how do we integrate them? And we start assessing what are the impacts, what are the challenges, and how we address them, but not really looking at them in details of power electronics. That's something that you need to learn in power electronics.
What we'll teach you is the very fundamental analysis and modeling of that. So then you have all the bricks, and then later on, you can put everything together, and then you will know what it's about. You will know the fundamentals. You have all the tools to do the next steps.
Well, I mean, from my side, yeah, as you can tell, we're always very excited about the subject. I mean, all the subjects of power engineering, to be honest. There are a lot of jobs out there, not just in the typical companies that manage the poles and wires or the system operator. The supply chain is massive. Jobs are in consultancy, jobs are in manufacturing, jobs are in policy making as well. They need engineers. So the ecosystem requires new brains, requires new ideas. So I think this is a great opportunity to expand the possibilities of having interesting jobs in electrical engineering. So hopefully we'll have some interesting brains joining us.
From my perspective, I'm a little bit more philosophical in the sense that for me, the really exciting part is in this, again, this modern world where everyone can say their own thing. It's really about giving you the tools to really understand what there is behind. When I say this is a unique subject, well, you will see at the end of the subject how much more you will understand of the real world and how superficial most things that are basically said are. You will really understand it at the end of this. So we will really have the possibility of gaining unique insights in terms of understanding the evolving energy system. Plus, all the practical benefits that Nando mentioned.